Hello YouTube. Today I'm here to teach you how to go from velocity versus time to position versus time graph. So, since we know velocity is equal to displacement over time, therefore displacement is equal to velocity versus time. Therefore, to go from velocity versus time to position versus time, we use area. And my name is Tolaz VT. Here we have a velocity versus time graph for a biker going to school. So, here he accelerates from 0 to 4 seconds, he accelerates. So, and then from 4 seconds to 8 seconds, he goes at a constant velocity. And then from 8 seconds to 10 seconds, he realized that he's going to be late, so he accelerates faster. And then from here to here, he has a constant velocity again. And then he starts reaching the school and slows down until he gets to a stop. Here we have velocity in meters per second north, and here we have time in seconds. So, on our position versus time graph, we will have position in meters north, and for a time we will obviously have seconds because we had seconds before. So here, in order to get our position from 0 to 4, we need to calculate the area. So, since area of a triangle is base times height divided by 2, so our base is 4 times height is 2 divided by 2. So therefore, we will have 4 meters. 4 meters. And on the position versus time graph here, let me just, 1 second. Okay, so for the position versus time graph, since here it's accelerating, so here we would have a curve. Therefore, so from 0 to 4 seconds, we have 4 meters. Therefore, here we go. We will have a curve. There we go. And in order to get the area here, so here, we will have to find the area of a rectangle, which is also a square in this case, but actually no, it's a rectangle. But so length times width is equal to area. So area is going to equal to 1, 2, 3, 4 seconds times 2 meters per second, so 2. Area is going to equal to 8 meters. Therefore, when we come to the position versus time graph, it should go up by 4 seconds. It should go up by 8 meters, sorry. So in the next 4 seconds, it should go up by 8 meters. 8 meters here would be 4 plus things, so 12 meters at 8 second mark. So I believe it's right here. Yes. So since there's no acceleration in this process, there's going to be a straight line going straight up. Here we go. There we go. So here, since we don't have a regular shape, we will split into 2 halves. So here, let's draw. Sorry. Here we go. And here we're going to split into 2. Therefore, this is going to be like that. We're going to add these 2 together afterwards, but first we got to find out the area of the triangle and the rectangle at the bottom. So, we have base times height divided by 2. Our base is 2. Our height is 2. And we're dividing them by 2. So therefore, area is equal to 2. And for the bottom part, we have the equation being length times width. Area is equal to length times width. And area is equal to length, which is 2, and and width being also 2. So area is going to equal to 4. And now to see what we're going to do here, we're going to have to add both of them up, which means area is going to be equal to, both of them combined is going to be equal to 2 plus 4, which means it's going to equal to 6. So since we got the acceleration at the area of this place and there's acceleration to it, we're going to put our point here, being 6 up, and we're going to make a curve since it's this kind of curve since it's accelerating. Now for the next part, we have a long triangle. So we're going to draw a line. Okay, there we go. So since it's a rectangle, our area equation is length times width. So area is going to equal to length, which is 1, 2, and the width is 4. So area is going to equal to 8. And now, to transition that into the position versus time graph, since there's no acceleration here, it's going to be a straight line. And we're only going to move up by, the position is going to change by 8 north. So we have here 12 seconds, and our current is 18, so 18 plus 8 is 26, so it should be around here. And no, it's here. Okay, there we go. So now we draw a straight line from here to here. So boom, there we go. So that's a 10 seconds to 12 seconds mark. And now for the final part, which is our decelerating. We are decelerating, but we still have a triangle with an area. So our equation is going to be base times height divided by 2. So area is going to equal to base, which is 3, times height, which is 4, divided by 2. Therefore, area is going to equal to 6. And now, since here we see it's decelerating, it's gonna have a different type of curve. It's gonna have the opposite type of curve. So from here, so let's count 6. Yes, 6. So at 15 seconds mark, and it's gonna 1, 2, 3, 4, 5, 6. So it's gonna have a curve a lot like this. So like that. It's gonna have a curve like that, which means it's decelerating, but then the position is still going up because the person's still going northwards. And there we go. So this is how you turn a velocity versus time into a position versus time graph. It's simple. You get the area of the velocity versus time graph, and you apply it to the position versus time graph. And then and then you always have to be careful with the acceleration and deceleration. You always have to draw curves, and depending on if it's accelerating or decelerating, you're gonna have to draw different types of curves. And that's about it. So that's how you go from velocity to position versus time. Thank you.